Okay, so the line L intersects AB at the point D. Show that the coordinates of D are -4 and 2. So line L and AB intersecting at point D. Now we've got the equation of line L, we've got the equation of AB. I've written them down here. So all we've got to do is solve them simultaneously, and we'll get then the point of intersection. Hopefully it'll be this, yeah? So what I can do here is maybe rearrange this, okay? Because we can't really add these, can't I? Or take away the way they are at the minute. So maybe number 2, I can say y will equal to 3x plus 14, okay? Because what I can do here is take that minus y over, it becomes a plus y, and y will equal 3x plus 14, okay? And then I can simply sub that then into 1, okay? So sub in 1. So I've got x plus 3y, so remember now y is 3x plus 14, minus 2 equals 0. So x plus 9x plus then 42 minus 2 is 0. So that'll be 10x plus 40 is 0. So 10x will equal to minus 40. So x will equal to minus 4. Okay, which is exactly what we wanted. Sub that then back into, well, it doesn't matter which one, you can sub it into 1 if you want. So we'll have minus 4 plus 3y minus 2 equals 0. So 3y will equal 6, which implies y is equal to 2. So therefore, D is equal to minus 4, 2, exactly as required. So then it says, show that L is not the perpendicular bisector of AB. Now let's have a look at the sketch again. Okay, there's AB, yeah, and it's saying that show that L is not the perpendicular bisector. Well, it's certainly perpendicular, isn't it? Okay, it's certainly perpendicular to AB because that was the definition at the start. Okay, but when it says bisector, it means that it cuts the line AB exactly in half. And from my sketch, which is pretty accurate, it doesn't it? It clearly doesn't cut it in half. But that's key there, right? To show here that it's not the perpendicular bisector. What we're going to do is we're going to work out that distance there, AD, and we'll work out the distance DB, which show they're not the same. If they were the same, it would be the perpendicular bisector. So what I'll do here is if I put in my point for D, which is minus 4, 2, and we're going to work out the distance. So we'll say distance, okay, distance AD, okay, will be square root of x2 minus x1 all squared plus y2 minus y1 all squared. That's the distance formula. So it doesn't matter what you choose, as I said before, as long as you're consistent. So maybe I'll call that my x2, y2. So x2, that will be minus 4. Okay, take away my x1, which is minus 7. So 2 minuses there. My y2 is 2. Take away my y1 then, which is 3. Okay, so on my calculator I'll work that out. So that comes out to be the square root of 10 there, okay? So that's the distance AD. So what I'll do then is if I work out the distance BD, so again, maybe I'll call that my x2, y2, and that'll be my x1, y1. So it'll be 2 take away minus 4 all squared, plus then 0 take away 2 all squared. Now, if it was the perpendicular bisector, this should come out as root 10. So when I work that out then, I'll actually get 2 root 10. So the distance there is actually double the distance here. Kind of looks it, doesn't it, on my sketch? So since distance AD is not equal to distance BD, we can say L is not the perpendicular bisector of AB.